Hello, this is Heather Ringstaff, and I am going to prove exercise 6.9 for my last video presentation. We are going to first assume that parallel lines L and L prime, have a common perpendicular, which is line PQ, and for any point X on L, we'll let X prime be the foot of perpendicular from X to L prime. And I'm going to prove that as X recedes from P on L, that this segment XX prime is going to increase indefinitely. Well, first of all, because we're in a hyperbolic plane, we have Hilbert's hyperbolic axiom of parallels, which allows us to draw limiting ray PY between ray PX and ray PX prime. So we can draw ray PY between ray PX and PX prime. And by crossbar, PY, ray PY, intersects XX prime at point Z on X prime. So by crossbar, this ray PY intersects XX prime at point Z. And because perps exist, we can drop a perpendicular from XY right here, to limiting ray PY. And by the definition of perpendicular, angle Y is a right angle, which makes triangle XYZ a right triangle. So triangle XYZ is going to be a right triangle. And by corollary 1 to the exterior angle theorem, if a triangle has a right angle, then the other two angles are acute angles. So therefore we have angle YXZ and angle YZX are acute angles. And by the greater angle opposite the greater side, we have that side XZ is going to be greater than side XY. And since it was given that angle XPQ is a right angle, because XPQ, that PQ was a perpendicular, we know that the sum of XPY and YPQ is going to be 90 degrees because angle XPY and angle YPQ are complementary. And that would imply that angle XPY has got to be less than 90 degrees, and therefore angle XPY is acute. And by Aristotle's unboundedness theorem, we know that as X moves away from point P on L, XZ increases without bound. Therefore, XX prime increases without bound.